Hello, my learner. Welcome to Manifestant e-learning platform. My name is Purity Anzelimo, your teacher of physics. And our lesson today, we are continuing with the topic electromagnetic spectrum. Electromagnetic. And in our lesson today, we are going to look at now the production and the uses of electromagnetic waves. So in this topic, we have been looking at the electromagnetic waves, and we've seen that electromagnetic waves, when they are arranged in order of their frequencies or wavelengths, they form the electromagnetic spectrum. And now in this lesson, we want to know how are they produced? How are the electromagnetic waves produced? How are they detected? And what are the uses or what are the applications of the electromagnetic waves? Remember, we listed down those electromagnetic waves. We can do a recap in order of their increasing frequency. We start with the one that has the lowest frequency, which is the radio waves. We also have the microwaves. We also have the infrared radiation. We also have the visible light. We have the UV radiation. We have the X-rays, and finally the gamma rays. So we want to know how are the radio waves produced, how are they detected, and how are they used. So we'll be looking at each one of them. By the end of the lesson, you should be in a position to state how each of the following electromagnetic waves, 1, are produced, 2, detected, and 3, what are their uses. So in an exam, for example, you can be told how are the microwaves detected. You can be told give one use of the gamma rays. And therefore, we are going to do a summary for all of them. We'll do a summary on how they are produced, how they are detected, and what are their uses. So we are going to have a table whereby we'll list down all the electromagnetic waves, their uses, how are they are detected, and how they are produced. So on one column, we have the EM waves. So we write the wave here. Then we have their production. How are they produced? We are going to do a summary. How are those waves produced? Then we'll also look at the detection. How each one of them is detected. And finally, we'll look at the uses. So that's what we are going to have a look at. So we'll start with the radio waves. We can start with the one that has the lowest frequency in that order and end with the gamma rays. So how are they produced? So it is key that you know how they are produced, how they are detected, and some of their uses. So we have the first one, which is now the number 1. We have the radio waves. Number 1, we have the radio waves. So we want to ask ourselves, how are the radio waves produced? And we can say that they are produced by the oscillating electric circuits. Produced by the oscillating electric circuit. You need to know that. And in the production, we can also say something about the radio waves. How are they transmitted? We can also write on their transmission. They are transmitted by the use of aerials and the antennas. Transmitted by the aerials and the antennas. That's how they are transmitted from the radio station to where they are being transmitted. We have the areas and the antennae. So that is the production of the radio waves. And they are detected using what we call the dions. In book 4, the last topic is on dions, that is on electronics. So we have the dions. They can also be detected by the use of what we call the earphones. They can also be detected by the earphones. What are the uses of the radio waves? They are used in radio communication. Used in radio communication. So that is on radio waves. Remember, we want to do a summary for all of them. So that is on radio waves. We can move on to number 2. That is now the microwaves. Microwaves. Now, in the production of the microwaves, they are produced in what we call the vacuum tubes, which are called the magnetrons in the microwave ovens. So produced by the vacuum tubes, which we are calling the magnetrons. The magnetrons, that is in microwave ovens. So that is what we have. And of course, during our last lesson in this topic, we'll be looking at some of the dangers of those microwaves. And that's why you are told that when you are using a microwave, you should be away from where you can have the radiations or where you can experience the radiations. But here we'll be looking at the uses, because we use these sorry, I've written in the wrong place. We have it here for the microwaves. Sorry. So we have it as this. These are the microwaves. They are produced. We have seen that they are produced in the vacuum tubes. That is the magnetrons in microwave ovens, or the oven. So that is what we have, and we can say that they can be detected using the solid state dions. The solid state dions. They can also be detected using the dry crystal detectors. The dry crystal detectors. And the microwaves, as we use them for cooking. We can use them for cooking. We can also use them for heating. Those are the uses of the microwaves. We are saying that they can be used for cooking. They can also be used for heating. So that is what we have for the microwaves. Then we can move on to the next one, which we are calling the infrared. So that is it, the radio waves. You can see the microwaves. Number 3, we move to the infrared radiation. The infrared radiation, and we see how the infrared radiation is produced, how it is detected, and what are the uses. So number 3, we have the infrared radiation. The infrared radiation. And with the infrared radiation, they are produced. One of the sources is the sun. Then we also have the hot objects or the hot body. Any hot body can produce the infrared radiation, the hot body. And we can also have the fires. Fires also is an example of a hot body. So we have the hot bodies. We also have the fires. That's how the infrared radiation is produced. Then how is it detected? One, we can use what we call the thermopile. We can also use what we call the bolometer. We can also use a thermometer with a blackened bulb. Thermometer with a blackened bulb. Remember, we know that thermometer is used to measure the temperature. Here we are talking of the infrared radiation. It has some energy in it. So we use now one which is a bit sensitive, that is a thermometer with a blackened bulb. We can also detect it on the heating effect produced on the skin. The heating effect on the skin. Heating effect produced on the skin, or simply on the skin. So that is for the detection of the infrared radiation. Again, the infrared radiation can be used for heating. Can use it for heating. We can also use it for drying. Also in agriculture, the infrared radiation is the one that is used to warm the greenhouses. Used to warming the greenhouse. The greenhouses. So we have those uses. So the infrared radiation produced by the sun, hot bodies, and the fires, detected using an instrument we call a thermopile or a bolometer. We also use a thermometer, but in this case it has a blackened bulb. Also the heating effect on the skin. When you feel some heating effect on the skin, that's how we detect the infrared radiation. The uses, we are saying that can be used for heating, can be used for drying, can also be used for warming the greenhouses. Then we move on to the other type of the radiation, number 4. Radiation number 4, we are having what we refer to as the visible light. So number 4, we have the visible light. And remember, this visible light is simply the light that you are using to see what I'm writing here. So how is it produced? So we have various sources of the visible light, and the major source is the sun. We also have the lamps. We also have the lasers as a source of the visible light. We can also talk of the hot objects. Hot objects. For example, when you have something like maybe the burning charcoal, it is also can be used to produce light. So the visible light, we are saying that is produced by the sun, the lamps, the lasers, the hot objects. And how can it be detected? It can be detected, one, you can be able to detect through the eye. So we have the eye. Hopes you get to up to here. So we have the eye, which is a major detector, the eye. We also have what we call the photographic film. Photographic film. That is especially used in photography. So the film, when there is light, it can enable the photographs to be taken, so it can be detected in the photographic film. And again, it can also be detected by the photocell. The photocell. That is now the visible light. And what are the uses of the visible light? One of the major uses, or one of the uses that is very simple, and that is what you are using here, is seeing. So we use visible light. It helps us to see. Again, it is also used in photography. In photography, that is another use of the visible light. Visible light can also be used in fiber optics. In fiber optics. Remember, in the refraction of light, where we learn about the fiber, the optical fibers. So there must be light, because in the optical fibers, we say that it is due to the total internal reflection of light. So there must be the visible light. So those are some of the uses that is in seeing in photography. We can also talk of the laser beams, also used in the laser beams. that is on the visible light. So we have the light amplification by the stimulated emission of radiation. So that is what we have for the laser beams. In another topic, we'll be talking of these laser beams. So those are the uses, and those are that is for the visible light. The production is by the sun, the lamps, the laser, the hot objects detected by the eye, the photocell and the photographic film used in photography, in seeing, in optical fibers, that is in optics, in laser beams. So then we can move on to the fifth electromagnetic wave, which is now the UV radiation. We know that the ultraviolet radiation, we know about the dangers on long exposure to the ultraviolet radiation, but again it has some uses. So we look at the ultraviolet radiation. So we have the ultraviolet radiation, the UV radiation as our number 5, UV radiation. The UV radiation, how it is produced. So we have what we refer to as the sun as a source, or as a source of the UV radiation. We also have the sparks. We also have the mercury vapor lamps as a producer of the same, the mercury vapor lamps. So they are produced by the mercury vapor lamps, the sparks, and also the sun. Then how are the UV light or the UV radiation detected? One is by the photographic films. Again, we also have the photocells. Photographic films, we have the photocells. We also have the fluorescent materials. When we talk of fluorescent materials, these are materials which produce some light or they glow. So we have the fluorescent materials. Then we also have paper smeared with oil, like Vaseline. So paper smeared with oil can be used to detect the UV radiation, because when it is directed to the UV radiation, it's going to burn, meaning that there is the UV radiation. So that's how the UV radiation is detected. And some of the uses, we have it as a source of vitamin D. So we get vitamin D from the sun, and it's due to the UV radiation, so it's important. Again, it can be used in treatment of cancer. Since these rays, the UV radiation, have a high frequency, they can be used in the treatment of cancer, and not just cancer, but the skin cancer. So those radiations are eliminated to the skin, and they are able to destroy the cancerous cells. So that is on the UV radiation. So that is our electromagnetic wave number 5 in order of their increasing frequencies. So we can move on to number 6, whereby we have the X-rays. The X-rays. In another topic, we'll be looking at the production of the X-rays. There is a topic that in book 4 that is on X-rays. And in that topic, we'll not be able to look at X-rays in details. So we have the X-rays as our number 6, X-rays. Their name was not yet known the time they were being discovered, and that's why they were called the X, for unknown X-rays. So we have the X-rays. How are the X-rays produced? X-rays are produced when fast-moving electrons suddenly hit a metal target. So they are produced when electrons, fast moving electrons, hit a metal target, produced by fast moving electrons, suddenly stopped by a metal target. So when you have fast moving electrons being produced and then moving at a very high speed, when they hit a metal target, they produce what we call the X-rays. They are detected using the photographic film. They are also detected using the fluorescent screen. So when they hit the screen, this fluorescent screen, it glows or it produces some light. So they are detected using the photographic film. You know that when you go maybe to the hospital to be undertaken an X-ray, there is the film that is used where the image is formed. Maybe it is the X-ray for the bone. So they are detected by that film and also the fluorescent screen. What are the uses of the X-rays? We have seen that they can, number one, be used to detect flaws in metals. In case there is anywhere where there is a flaw in a metal, they can be used to detect. So detect flaws in metals. So in case the metal has a breakage, it's able to detect. Again, it is also used in the study of crystals. That is what we call the crystallography. In the crystallography, we have the X-rays being used. Again, they can also be used in the study of fractures. The study of fractures. Again, when you get to the hospital and maybe you have you had an accident and they tell you to undertake an X-ray. So that X-ray is used to study your bone, whether it has what's the issue with it, and they are able now to be used in that study of the fractures. Because as we can see, as we are moving from the radio waves, the X-rays have high energy compared to the others. That is the radio, the microwaves, the infrared visible light, and the UV radiation. And therefore, the X-rays can be able to penetrate through the flesh. They can be able to penetrate through the flesh, and therefore they can be used in the study of fractures. When we'll be talking about the X-rays in the topic X-rays, we'll be able to see which type of X-rays is able to penetrate through flesh and which one is able to penetrate through the bones, and it can be used in that study of the bones. So lastly, we have our last electromagnetic wave, which has the highest energy and it has the largest frequency. That is what we call the gamma radiation, or simply the gamma rays. The gamma rays. Gamma rays, how are they produced? They are produced when a radioactive substance undergoes some disintegration in the nucleus of an atom. So they are produced by radioactive substances in the nucleus of an atom. So in the topic radioactivity, that's where we talk about the radioactive substances. They are not stable, they keep emitting. They keep emitting rays, and one of the rays which is emitted, or one of the radiations which is emitted, is the gamma rays. So they are produced by the radioactive substances in the nucleus of an atom when they undergo that disintegration. So they are detected by the photographic plates. We have the photographic plates. We also have the radiation detectors. And a good example of the radiation detectors is what we call the Geiger-Müller detector. The Geiger-Müller detector under the topic radio activity, the Geiger-Müller detector, or what we call the Geiger-Müller tube. It's a tube. It is able to detect the gamma radiations. So we have the gamma rays. They are produced when a radioactive substance undergoes some disintegration. They are detected by the photographic plates, also detected by the radiation detectors into the Geiger-Müller tube. Then how are they used? We can say one, they are used to kill cancerous cells, or the tissues used to kill the cancerous tissues. So in medicine, we can use the gamma rays in treatment of cancer because they can be able to destroy the cancerous tissues. Then they can also be used to sterilize medical equipment. They are also used to sterilize the medical equipment. And this is due to their high energy. Due to their high energy, they are able to kill the cancerous tissues, and they are also able to sterilize the medical equipment. So those are the EM waves, how they are produced, how they can be detected, and some of their uses. So you should be in a position to state, if you are asked how are the X-rays detected, you should be able to say that they are detected by the photographic film or the fluorescent screen. How are they used? They are used in detecting flaws in metals, crystallography, study of fractures. If you are asked how are the microwaves used, you shouldn't be able to tell. They are used for heating, they are also used for drying, they are also used for cooking. So that is it on the detection, the production, the detection, and the uses of the EM waves. So during the next lesson, we'll actually now be looking at, now that we have looked at the uses, we know that long exposure to these waves can be hazardous, and therefore we'll be looking at now the hazards or the dangers of these EM waves. That will be our next lesson, because we have always seen that you should not go for an X-ray so many times, especially the sensitive areas in the body, because it can lead to cancer again. Despite the fact that it has all those uses, again it can be dangerous to our health. So we'll be looking at the dangers, and that will be the last lesson in this topic. So I want to leave you with some work on stating whatever we have been able to look at. I would like you to state 3 uses of the infrared radiation. State 3 uses of infrared radiation. Then number 2, how is the UV radiation detected? How is the UV radiation detected? How is the UV radiation detected? And lastly, how are the X-rays detected? How are the X-rays detected? So as I've seen, now that we have been able to write the whole summary here, you should be in a position to go through it every now and then, so that you can master how each of the EM waves are detected, how they are produced, and how they are used. So during the last lesson, and that is the end of the electromagnetic spectrum, we'll now be looking at the dangers of the electromagnetic waves. So till we meet during the next lesson, thank you for your time and also for being keen on what we are looking at. Thank you.